talk about the logistic programming of the controller. So here we have the controller. We have the buttons which will control the Workcell, as you see here. We have 3 logo controllers which control the logo output of the feeder. We have double operator start, which will start the program. We have the reset button for safety measures. An E-stop to stop any motion the robot is doing. An MCR button to turn on and off the MCR. A program light that's on when the motion is going. And a stop light when there's no motion but the program is still on. Now, right here we have the program on the computer. This controls what the scorebot is doing at all times. As you can see, I have safety measures implemented to control the light curtain and the emergency stop button. As you can see, input 8 controls the light curtain and input 9 will control the button. So that means when the program is going, if there is an issue or a problem we have to solve, I could press the E-stop button, which will stop motion of the controller, and I can go and work. Press the reset button and procedures will go again. Now, to make the logos work, I have subroutines and jump to commands, which will set variables to the letter B. Now, this letter B will designate the position that the robot goes to when it picks up the stick and lays it down. After that is the same motion after that, so nothing to worry about. Now, I have 2 subroutines in this command structure. I have one for the light curtain and one for the E-stop. That is simply for safety measures and keeps anyone who's around here safe. And that is the logistical programming of it.
Hi, I'm Tyler Lee. I was the main electrician for our Workcell. So here we have all the wiring for ours. We have the main controller for the robot tucked into the computer. We have the light curtain box, which worked and would make sure that the 2 light curtains have a signal. Down here, you can see that the controller, we have DC, positive and negative. Here's all of our outputs, all with yellow wires, all our inputs with green. Everything's labeled. We have our AC, positive and negative, and we have a circuit breaker on it just for safety reasons. Each one of these is put with a fuse just so if anything goes wrong it doesn't destroy the controller. Everything runs through these tracks for safety and just to make it look cleaner. And they either will go to relays, which go to the pneumatics or fans or whatnot. Blue is for DC, red was for AC. And then over here we have our valves, each one for a different pneumatic of air. And that's about it. The rest of it just goes into the controller, which is what Alex did before. And later on you'll hear about David and Curtis talking about all the fixtures on top and how they're hooked up with the wiring.
I'm Curtis, and my job was to work on this half of the fixtures we have. Over here we have our logo feeder, which will feed out the logo bases. As you can see, we have 3 logos, the P for PHS, the U of M, and the MSU S. When they come out, just a little rubber logo like this. Then the robot will come over here, pick up one of the bases, which the optic lets you know it's there. Set it on the preparation plate. It will come pick up the glue from the glue station, bring it over, glue on it, put the glue back, come over, pick up the desired logo that the user selected, take the logo, in this case an S, bring it over, set it down on the preparation plate, and it's glued.
Alright, I'm David. I was in charge of this half of the pictures. After the robot glues the stamp, it'll take it over here to the fan where it'll set it down and it'll dry it for 4 seconds. After that, it'll pick it up. That box will be pushed out through the box feeder. The robot will then put the stamp into the box and close the box. Then the robot will come over, pick up the box, put it down there, and there's your stamp.
on